Hello, I'm back. All right, now we're going to do a water module uh, installment number 2. All right, back with this graph for a few minutes. Just make sure we are conversant in it because there'll be a couple of more versions of this, homework, test, final, you name it. Everything's backwards in recording here, so one hand is in the way and the other one's moving. All right, I've shaded in something here. You can see that over there. Suppose you have demand D2, right? That's this one right here, okay? The one that's furthest out. Okay, suppose you have demand D2, all right? And now price equals marginal cost. The efficient policy is 288, all right? If you charge 288 for all the water, all right, you'll make that shaded area as a net revenue, or in the private vernacular, a profit, right? Because the demand at the 288 will be 600, and 348 out of the 600 will be water from your cheap $128 an acre foot source, and you'll be selling that at 288. So 288 minus 188, 160 times 348. That'll be your profit. Now, I started off with that. Oh, let me do one other thing before we follow up with that. Well, how do you avoid the profit? We talked about one way to do that. That was with the average cost pricing. Now, let me go ahead and finish up with that. The other way to do that is called two-tier pricing. Okay, and this is practiced in at least some places that I know of. And it has not only political advantages, but to the extent that the marginal cost is so high that it could actually become a burden for small volume purchasers, low-income households. What you can do with the two-tier pricing is to make sure that the first increments of water, perhaps enough to not have any profit at all, or at least enough so that low-income households can have acceptable water bills, what you do is you have the first increments of water sold really cheap. For example, maybe just to utilize this graph, at $128 an acre foot. Okay, and then after every household gets some water cheap, all of the remaining water that they purchase would be at the 288 marginal cost for the water given demand D2. You want all the users to be purchasing some water at the highest price so that their decisions at the margin of how much or a little more or a little bit less water to purchase has a $288 per acre foot impact, depending on whether they're purchasing a little more or a little bit less. You want them to feel the true cost of the water, at least at the margin, okay? Because that's the signal that makes their use efficient, so that they don't have any uses that aren't worth $288 per acre foot. Okay, so a low lifeline rate to avoid profit and or to provide a lifeline to truly poor households that would struggle to pay a water bill that was all charged at the $288 per unit price. Okay, so that's one way to do it. Now, the other thing that I wanted to cover with this graph was just to make sure that you're reading it correctly. Let's just go back to this demand D0. Okay, there again, everything's hunky-dory there, both efficiency-wise. Politically, the price is $128 per acre foot to everybody for every gallon for every acre foot. Okay, and we use the system up to its capacity at the 348. Okay, and no profit. SAWS pays its bills, whatever. All right, now the demand increases. Oops. See, now at that $128, we have a shortage. Whoops. Bring that graph back up here. See, with demand D1 and still $128 price, right? Because that's what it costs to deliver the water. The quantity demanded is 492, and the quantity supplied is only 348, and so we have 144 shortage. Okay, so that's not okay, right? I mean, the tap turns, the water's got to come out. So then the question is, what do we do about that? And what's often done about it is somebody goes and taps into a very expensive water source that dissipates that revenue over some highly costly source of water, so that the politics is that, yeah, the extra money you're paying is actually providing additional water. Right? It's not efficient to do that until demand gets past D1, until it gets past intersecting the marginal cost line here at this point, right there where the kink is, where the goes from vertical to horizontal, okay, on the marginal cost line. Okay, so we're going to put this down and move on to other things. We're going to talk about the actual major sources of inefficiency that are out there, especially in the United States, in the western United States, where that makes the most difference, because where water use, water demand is more often than it is in the eastern part of the United States, close to or threatening to exceed the amount available. All right, so one of those is that quite often the government is involved in adjudicating the uses of the water, and it assigns use rights to the water, but not ownership rights. Okay, and then it applies things like the beneficial use doctrine. And, well, you say, well, duh, well, of course. Well, see, exactly, that's what the vast majority of voters are thinking. Well, of course, we're not going to provide somebody an allocation of water unless they can show that they're going to beneficially use it. Now, in our economics vernacular, all that means is the marginal benefits above zero, but it doesn't mean the marginal benefits above the level at which somebody else has to start doing without. And see, again, therein lies the reason to have trade and to have ownership rights rather than just use rights. Because, see, if they're just use rights, it's very hard to have transfers. Also, there may not be much incentive to have a transfer, because if you can't sell it for money in your pocket, right, it being some of your allocation of water, you're just going to stick with what you have. And then further, this wonderful sounding beneficial use doctrine may make you actually waste water just to prove that you can, or at least at times you will, beneficially use it. So for example, let's say that for whatever reason, and your business is down, or if this beneficial use doctrine were to apply to household levels, maybe you've traveled a lot, you don't want your water use to be curtailed. So you send somebody over to your business or your household, tell them to turn the tap so that the meter will spin, so that the use that you can document will actually be at the level, even though you didn't put the water to any very useful, maybe you watered some plants, right? Pour the water out on your lawn or something. Didn't need it all that bad, but hey, you've got to show that you used as much, that it went through your pipe and out to something as you were assigned. Otherwise, the water authority could say, hey, you don't need all of that water that we've assigned you. You're not beneficially using it. We'll just take it, give it to somebody else. And maybe in a different year, you would want to have that much water. So you don't want to do without, and you have no incentive to pass it on to others, right? Because it's just a use right, not an ownership right. And so anyway, the beneficial use doctrine begets waste for people to demonstrate through a documented use of water that they used all that they were allocated. Now, one of the things about making things political is that it's very hard to produce change, because people will always vote their existing pocketbook, right? So what happens when somebody proposes to reallocate existing water uses, say, based on efficiency? Well, many of those that are benefiting from the existing allocation of water, maybe as a downstream beneficiary, and I don't mean that literally in terms of downstream. I mean because person A used water in a certain way, person B did something, and then person C has a sale to person B as a result of person A doing what they did with their water. If person A says, I want to sell my water to person X, then person C says, that'll hurt my business, because person B won't be doing what they're doing anymore, and they won't buy my stuff from me anymore. Like farm use of water, agricultural water. If that's diminished because the farmer says my water is more valuable used in the city, then the local feed supply store says, or the local cafe says, there won't be as much activity here in our town via agriculture because some of the water's left, and the farmer might shut down or change the crops that they grow. No, ka-ching with my vote. No, I'm writing my legislation, because, what cost is there to you as person C to block that, other than you have to contact your legislator and say, no, that's not good for our town or good for my business or whatever. Don't you let person A stop doing what they're doing and sell their water off to San Antonio. Okay, again, using local examples. So we have problems in that they're use rights and use it or lose it, beneficial use doctrine. And we have another one, by the way. It's called the no injury doctrine. Again, for the average voter who doesn't pay much attention to politics, what could be more obvious than to support beneficial use of water and a no-injury doctrine. Well, the no-injury doctrine means we've got to make time stand still, and we can't let market forces decide that older uses of water aren't as valuable anymore as some newer uses are, and use the price mechanism to cause willing buyer, willing seller trades that might have what are called pecuniary externalities. Keep that term in mind, because it'll come up again when we talk fisheries. When physical externalities, we've talked about those. That's when stuff comes out your smokestack, you harm somebody downwind. That's a physical externality. A pecuniary externality is when you change your buying or your production habits, and that impacts somebody negatively down the road, downstream, not water stream, but in terms of transactions downstream. And they say, no. If I have the political power to veto that, no, we don't want to do that. We want to make, the local farmer, he can sell his water if he wants to, as long as he does it by salvaging it. What does that mean? As long as he doesn't change what he does. If he can figure out how to keep doing what he's doing or she's doing. But to do it with less water, oh yeah, sure. You take the salvaged water, the water conserved, right, by more efficient use of the water. They can sell that one. That's useful, right? I mean, that's yielded some water for San Antonio and for other urban areas but it still leaves a big gap in the MMBs between some water users and others. Might be perfectly efficient economically to have all of that water, not just the amount that can be conserved and cause the same economic activities to move forward with less water. But anyway, so salvage rights are useful, but are not sufficiently change or sufficiently resource allocation conducive as they should be. All right, so making things political undermines change. To understand this, you need to look at a picture of Cuba. I mean, there's where, everything's political, right? Have you seen some pictures of it? Google it sometime. You'll see that they're still driving to the extent there are any cars left that are functional. But they figured out, since they can't get many new ones, they're still driving 1950s, with the fins and everything, because time has basically stood still when you make things political. And there, it's not even based on voting. It's based on a different reason why this time stands still. But even when it's based on voting, that part of the way resources are allocated, it's difficult to move forward. You can't move water, or it's difficult to move water out of low value uses to higher value uses. There are farmers producing, like in California, baseball size, softball size grapefruit, and water is worth to them, $40 or $50 an acre foot. At the same time, a city a couple hundred miles away is spending thousands of dollars an acre foot to put new water into their systems. It's, as I say, when you make it political, some wacky things happen, and I can explain it to you with a smile on my face, and even laugh a little bit. But when you look at what it does to economic growth, it just isn't funny, right? Because those are massively wasted resources to build a giant dam somewhere, when you could, under non-political circumstances, arrange willing buyer, willing seller trade. And yes, the downstream uses, the businesses that depended on the farmers growing their grapefruit-sized, their softball-sized grapefruits, they're going to have to adjust, but that's the nature. Of course, they don't want to adjust. They would much rather go boop and cast a vote and say, no, I don't want to adjust. I want to keep things the way they are. I want to keep selling my products to the farm that's growing the softball-sized grapefruit. Okay, so enough of that for the moment. What's another reason that water use is inefficient? Again, especially in the western United States, that starts pretty close to here. We're probably not too far east of San Antonio in terms of water scarcity. In one place that I live, where I earned my PhD at the University of Wyoming, when I was there, and hopefully they figured out how to change this politically since then. When I was there in the early 80s, the city of Laramie, Wyoming, where the University of Wyoming is located, was growing, and had to have, they thought, I don't know what their pricing situation was and whether they just thought they needed additional water or whether they really did based on efficiency criterion. But anyway, what they had to do in order to bring additional water rights to the city of Laramie, they had to buy a ranch with really old water rights. And normally what you would do is just buy the water rights. But now in Wyoming, then, and perhaps still, you had to buy the land. You couldn't separate the water rights from the land. So the city of Laramie had to park some distance from the city of Laramie, this old ranch that they had to buy in order to be able to take the water rights attached to the ranch and ship that water to the city of Laramie. Strange stuff. By the way, it's also a divisibility issue. Maybe the city of Laramie didn't want all of that water. Maybe it would have been better just to buy, say, half of it, and leave the other half of it in the ranch, or let the ranch sell it, the other half of it to somewhere else. Maybe it's time to make the ranch a hunting preserve, sell off most of the water rights that go to it. But as they used to say on the old Saturday Night Live, but no, the water rights were only saleable along with the land, and so the city of Laramie purchased the whole thing. I'll have to look that up someday to see if that's still the way things are done there. And of course, there was a good reason for it at the time. The land was, in the old days when that law arose, the land wasn't worth much without the water rights attached to it. So they went as a package deal. Well, times have changed, but because of those downstream effects, again, sorry for the pun, but by transactions cascading forward, people resisted that change, and they may still have successfully resisted change in that law. All right. Another reason for inefficient water use, again, especially in the western United States, are interstate compacts. What is an interstate compact? Well, it's a way for multiple states to divide up the available flow of a multi-state river. For example, the Colorado River. I don't mean the one that runs through Austin. No. That's not an interstate river. All of it's in Texas. All of the watershed's in Texas. No, I'm talking about the one that goes through the Grand Canyon, right? That Colorado River. Right? It starts, the Green River and the Colorado River meet in Canyonlands National Park in Utah. And then the Green River is, at that point, every bit as big as the Colorado River, and it starts up in Wyoming someplace. And another major tributary of the Colorado is the San Juan River, and parts of it go through New Mexico. So by the time you figure out all the major states that have some interest in the water that either is in the Colorado River or will be if it's let go downstream, we're talking New Mexico and Wyoming and Colorado and California and Arizona and Nevada. I think that's all of them. Arizona, had I mentioned that one? Anyway, back in the 1920s, they decided that the average flow of the Colorado River was about 15.5 million acre feet. And that was part of the problem with the river, with the interstate compact. They were basing that on poor data for a rather wet period, because if you've ever been to the Colorado River, if you've been there recently, you know that the two major reservoirs on it, Lake Mead, which is between Nevada and California and Arizona, and Lake Powell, which is Arizona and Utah, I think exclusively, yeah. They're way, way down. And that's because through the interstate compact, the states have been drawing their share of 15.5 million acre feet, which has been more than Mother Nature has been putting in those lakes to be taken out. Now, hopefully we'll have some mega year like 1982 and 83 again in the near future, because those lakes have got plenty of capacity to hold a lot of water. I drove around there, by the way, once in 1982 and 83. Lake Powell, gigantic lake, 1,900 miles of shoreline, was so full, they were afraid to let water out any faster than they were, that they stuck some metal planks across the top of the dam so that it could fill up above the normal height of the dam for a while, so they could retain the water in there for a while before releasing it downstream. The river rafters, they loved going through the Grand, well, as long as they didn't want to take very long. They loved going through the Grand Canyon because the water was just pouring through there. It was a really fast ride. But anyway, back to the subject at hand. The Colorado River has not been back in the 1982-83 mode since. Hopefully it will again, and the lakes will fill back up. But for now, the river is over-allocated, so that's a problem with the interstate compact. And more importantly, for our sake, for our discussion in terms of inefficiency, the water allocations to different states, to California, Arizona, are very difficult to change. It's very difficult for a state to buy off water from another state, even though the MNB differences between, say, Wyoming and California are enormous. The marginal use of Green River water, a tributary to Colorado in Wyoming, is growing hay, which is not a very valuable use at all. In California, it's municipal use. It may be filling swimming pools, which is often what was joked about. But it's a use that people are willing to pay a lot of money for. It's a high value use based on willingness to pay. Okay, so swimming pools in Palm Springs and Los Angeles were competing with growing hay in Wyoming, but they're still growing the hay in Wyoming, and they're struggling to fill up the swimming pools in Palm Springs, and that's a source of inefficiency. West California is finding other places to get water from that are more expensive than potentially a willing buyer, willing seller trade with Wyoming. So why doesn't Wyoming sell off its water? Well, Wyoming has its aspirations. Just other states, same thing, has its aspirations for economic growth, and they're afraid that if they sell their water off, which they would love to do now, as long as they could believe that they could get it back if and when they wanted to support their own growth. See, therein lies the problem. Interstate compact water is not seen as readily movable. Any transactions are seen as permanent and forever. Okay, again, California would love that, Arizona would love that, and Wyoming not so much so, even though they may never get, Wyoming still has not as many people as all of San Antonio. It's not even close to that many. The whole state of Wyoming. Big, geographically small population-wise. But even so, they have their hopes and dreams for growing, and we'll need that water then, and so they're not willing to give it up. If we had a real market for that water, to where at any given day there was an observable price, a willing buyer, willing seller trade, that problem would go away because Wyoming would know that they can make money now and then later when the waters would be available for whatever the going rate is then. But that's not the perception. The perception is that transactions are not easily made and that they would be permanent forever. And so these interstate compacts are huge sources of inefficiency because of the difficulty of moving water from places where it generates very little economic value to places where it would generate much more. Despite the joking about the swimming pool, that is the basis of value, willingness to pay. And those uses that want to fill up their swimming pools are competing now with other uses in California and causing the state to, well, for example, to have built the State Water Project, which takes water from Northern California to Southern California at very, very, very high cost. When that might not be necessary if they could just get some more water through their pipeline in California from the Colorado River, having purchased water rights from upstream users like Wyoming, and probably Utah might have some available on a willing buyer, willing seller basis. All right, so these various institutional hurdles like interstate compacts and contracts with individual federal water projects, mostly irrigation, these transfers are very difficult to make, and so some legal reform would go a long way towards saving a phenomenal amount of resources, especially in the western United States. Right, probably though the biggest impediment to water transfers, once you set aside some of these big picture interstate compact federal water project type issues, the biggest issue is what are called third-party impairment claims. And basically what that means is that when somebody sells water from one diversion point on a river, mostly, not so much a lake, that's not big an issue. Third-party impairment claim is not this big an issue there, because a lake is, the water moves, keeps the lake level constant, right? Whereas if you take it out of the river upstream or downstream, it's got to go past a bunch of things upstream first to get there. And anyway, so the bigger issue is for rivers, and some of the issues that we've been talking about are sort of overlapping because of the use right versus ownership right thing. The entities, the governmental entities that process these claims or these desires for moving water from one user to the next based on payment prices, have been quick to deny these based on somebody complaining that they would be an indirect loser if person A were able to sell water to person B, because not all of person A's water ever is used up, and some of it goes to person C as a result of returning to the river after it gets poured on somebody's land. Okay, so these third-party impairment claims and the way that they've been processed, namely, some third party is going to be harmed or possibly harmed by somebody selling their right to divert water from one point of the river to another point, or by somebody even just changing the way they use water that they can divert, that they have a current use right to divert. Instead of providing for or allowing compensation in some states, some more than others. It's nope, we just can't do it. Just water use and water diversions have to stay the way they are in order to follow the no injury doctrine. Remember that. Yeah, we can't take any chance that anybody might be injured by reallocating water, even if it would be enormously beneficial. Right? If anybody would be injured even a little bit, remember, because it's use rights, the water may not even be theirs to really sell. It may be the government just says, well, it's more valuable here than here. Let's move it over to here. And no, I guess we can't do that because somebody over here would be indirectly harmed. Maybe not very much, but, they're harmed. I mean, they're going to complain, and a vote's a vote, and a lawsuit's a lawsuit. It doesn't matter what somebody's, unless you allow the one to compensate the other, and that's not so much been allowed. So government ownership dominates the uses of water. That's another issue, is that governments are not profit-making entities. Thankfully, most of the time, we're thankful for that. But in other cases, it's just that they don't consider the differences in the water value uses to other governments or other people on the same water source, and so that hinders trade to some extent as well. One of the slides that we're going to look at in the PowerPoint when we get into class is slide 12, and that shows some data about a particular place where they've had some water transactions. And you can see that not all the prices are the same. And another thing you see from the slide, I won't put it up here because there's a lot to look on there. And I guess, well, I could. You could freeze it later on. But anyway, it's there in PowerPoint slide number 12. And it shows that water markets typically are somewhat thin. And again, this might be because there aren't that many trades, because so many of them are denied or impaired by reasons that we've been going over. But it may be just that large amounts of water is going to be what is traded, and there's enough water to have that moved around a lot, and there's a lot of investments involved in moving around water. So water markets maybe are inherently thin, not just because of government restrictions on transfers. And thin means not very many transactions, means that there's not a going rate established. You can see that from the data on that slide, that trades or leases. Let's see, a lease means, okay, you can use it this year and it's back to me next year. A sale means, permanent transfer. I'm giving up this water forever. You can see the prices are different based on that. Well, the leases and outright sales should be different, but among different, those ought to be the same in a thick market. But in a thin market where you can only find one or two buyers at a time, and you sell to the one offering the most, you can get different prices on different transactions, and you get that there. Okay, now we're up to the point of the preferential use doctrine. I've already condemned this one time, but now it has a name. Okay? There are places that actually do. And again, it does sound good, doesn't it? Preferential use doctrine. It's these uses are preferred to these uses. Yes, we value municipal uses over industrial uses, or those are people, households, and provide them water. But it's not true. And here's where the understanding of some basic economics comes in, and because it's rare, we get these inefficient policies. The preferential use doctrine basically says that the last drop in a higher preferred use, higher valued politically, preferred use is worth more than the first drop in a next less preferred use. Just not the case. And so, again, it sounds good, but it's not wise, and we should eliminate them if we possibly can. So just kind of take a deep breath here and we think about water. Whoa, there's a lot of problems, and we're not even we're still going to spend some time on quite a bit more time on water beyond these first couple of videos. What does this mean? It means just kind of give up and okay, the government's going to just control it, and maybe we should just figure out a way to have some salvage right water move and just accept the fact that the political process doesn't allow water use changes very readily. I don't know, but I think what it does mean, based on experience, is that when there are big obstacles, big opportunities, right? So let's not be pessimists and say, why study the efficient use of water? It's just not going to happen. Well, maybe we can make it more efficient at the margin. Maybe we're not going to overcome all these hurdles in all states at one time, but maybe because of the potential gain, which is in the tens, if not hundreds of billions of dollars, Read some stuff that's been written about Texas water. If we don't figure out a way here in Texas to more readily move water from existing low value uses to higher value uses, we are going to spend a phenomenal amount of money and have to raise state taxes a lot, which will hurt our economy a lot, in order to accommodate the high value uses while leaving existing water sources in the low value. It's going to be very expensive. So all of these enormous obstacles, I think, suggest first and foremost enormous opportunities for creative people like you. And they also suggest working at the margin to move forward and to demonstrate how improved efficiency can be had, and hopefully, and that be part of the process to achieve that more efficient, greater efficiency on a big picture basis. The last thing that I want to discuss in this second installment of the water module video is back to the prior appropriation doctrine, because I do want to emphasize that, again, it is potentially the basis of a system that meets our two criteria, which let me repeat those again. Equal marginal net benefits across water users, and then the second criteria would be, keeping those equal given year-to-year variability in supply. Okay, so the prior appropriation doctrine is probably has the potential to be the very best way to allow us to achieve both of those objectives, provided that the water rights are divisible, okay, and easily transferable. Otherwise, it's a total disaster. And why is the prior appropriation a total disaster in the absence of both of those things? Well, because the oldest water rights, the most senior water rights, are in today's uses the least valuable, typically. As I mentioned a few minutes ago, the oldest water rights came from the first people to move in a certain area. They weren't building cities. They weren't building giant industries. They were building farms and ranches, right? And so then they adjudicated, or they perfected their water rights to be able to run those ranches, right? And so those are under the prior appropriation, those are the really valuable water rights, the oldest, the most senior water rights. But if they're not divisible, in other words, if that property can't move on some of those water rights to higher value while retaining some, and can't manage those transactions, then those water rights are stuck in those really old, really now low value water uses. All right, so keep that in mind. Prior appropriation doctrine is potentially the basis of a very efficient surface water management system, but is potentially a disaster too if water is not readily transferable, water rights are not readily transferable, and are not divisible, so that an initial water right of, say, 100 acre-feet can't be divvied up into 100 little pieces of paper, each for 1 acre-foot, each retaining that 1870, whatever really old date that makes it really valuable, right? So that each division of the bigger piece keeps that high priority on all the little pieces. All right, that's the end of water installment number 2, and additional installments here for the water module will occur in the near future, and hopefully in time for our discussion in class. Otherwise, we may have to move things around a little bit, just timing-wise, to discuss other things while we wait for these modules, these videos to post. All right, so that'll do it for today, for me, and for water modules 1 and 2. Private vernacular, a profit, right? Because the demand at the 288 will be 600, and 348 out of the 600 will be water from your cheap $128 an acre foot source, and you'll be selling that at 288. So 288 minus 188, 160 times 348. That'll be your profit. Now, I started off with that. Oh, let me do one other thing before we follow up with that. Well, how do you avoid the profit? We talked about one way to do that. That was with the average cost pricing. Now, let me go ahead and finish up with that. The other way to do that is called two-tier pricing. Okay, and this is practiced in at least some places that I know of. And it has not only, there again, everything's hunky-dory there, both efficiency-wise. Politically, the price is $128 per acre foot to everybody for every gallon for every acre foot. Okay, and we use the system up to its capacity at the 348. Okay, and no profit. Saws pays its bills, whatever. All right, now the demand increases. Oops. See, now at that $128, we have a shortage. Whoops. Bring that graph back up here. See, with demand D1 and still $128 price, right? Because that's what it costs to deliver the water. The quantity demanded is 492, and the quantity supplied is only 348, and so we have 144 shortage. Okay, so that's not. Hello, I'm back. All right, now we're going to do a water module installment number 2. All right, back with this graph for a few minutes. Just make sure we are conversant in it, because there'll be a couple of more versions of this, homework, test, final, you name it. Everything's backwards in recording here, so one hand is in the way and the other one's moving. All right, I've shaded in something here. You can see that over there. Suppose you have demand D2, right? That's this one right here. Okay, the one that's furthest out. Okay, suppose you have demand D2. All right, and now price equals marginal cost. The efficient policy is 288. All right, if you charge 288 for all the water, all right, you'll make that shaded area as a net revenue, or in the political advantages, but to the extent that the marginal cost is so high that it could actually become a burden for small volume purchasers, low-income households. What you can do with the two-tier pricing is to make sure that the first increments of water, perhaps enough to not have any profit at all, or at least enough so that low-income households can have acceptable water bills, what you do is you have the first increments of water sold really cheap. For example, maybe just to utilize this graph, at $128 an acre foot. Okay, and then after every household gets some water cheap, all the remaining water that they purchase would be at the 288 marginal cost for the water given demand D2. You want all the users to be purchasing some water at the highest price, so that their decisions at the margin of how much or a little more or a little bit less water to purchase has a $288 per acre foot impact, depending on whether they're purchasing a little more or a little bit less. You want them to feel the true cost of the water, at least at the margin, okay? Because that's the signal that makes their use efficient, so that they don't have any uses that aren't worth $288 per acre foot. Okay, so a low lifeline rate to avoid profit, and or to provide a lifeline to truly poor households that would struggle to pay a water bill that was all charged at the $288 per unit price. Okay, so that's one way to do it. Now, the other thing that I wanted to cover with this graph was just to make sure that you're reading it correctly. Let's just go back to this demand D0. Okay,